Hello everyone. In this video, we're going to start taking a look at some special pairs of angles. And I also want to take a look at how we can work with these special pairs of angles when solving problems. So let's start off with a couple definitions. The first two special pairs of angles I want to look at are complementary and supplementary angles. So let's start off with the definitions. So complementary angles, these are angles that have a sum of 90. Specifically, they are two angles that sum to 90. So to put that in a diagram so we can visualize what this looks like, if these were right next to each other, they would form a right angle because they have a sum of 90 degrees. So here's a right angle. I can indicate that this is a right angle with a little box in the corner. And then let's split this into two different angles. So it doesn't matter what it looks like, we'll do something like this. And I'm going to name these angles angle 1 and angle 2. So the definition for complementary angles is when I add their angle measures together, I should get 90 degrees. If I compare that to supplementary angles, supplementary, this means two angles that have a sum of 180. So it's a very similar idea. The only difference is instead of adding up to 90 degrees, these add up to 180 degrees. And again, we'll put a diagram with this so we can visualize it. So 180, that makes a straight line. And then we'll split this into two separate angles. And we'll name these angle 1 and angle 2. So the definition of supplementary tells me that when I add the two measures together, I get 180 degrees. So 90 and 180, these are used very frequently. A lot of applications are going to be looking at right angles or looking at straight angles. So 90 and 180 are useful. And because of that, we like to give these names. It's easier to refer to them when we have a specific definition set out for these two words. The other thing I want to point out here is the way that I drew these angles are right next to each other. They share a side. When angles share a side, I say that they are adjacent angles. So I'm just going to make a little note. So I'm down here, I'll say adjacent angles are ones that share a side. So that's just a little extra note. But complementary and supplementary angles, they don't need to be right next to each other. They could be two separate angles. As long as the measure of those angles add up to 90 or add up to 180, they meet the description. So they don't have to be next to each other, but they certainly can be. Now, let's use these ideas in solving a couple problems. So the first one, so right away in this first sentence, I have a couple angles, angle BCE and angle DCE, and it's telling me that they're supplementary angles. Okay, so right away, I see that word. I know that these add up to 180. And then I'm given some information about what they're represented by. So the measure of angle BCE is represented by 4x plus 8, and the measure of angle DCE is represented by x plus 2. I always like to start with a diagram, so let's do that. So supplementary, they're going to add up to 180. So that means two angles, and then they're going to form a straight line. And then let's label this. So I'm going to put some points on here. And then taking a look at how my two angles are named, I have BCE and DCE. Both of those angles, they share the two letters CE. So that's telling me that's the shared side. So this is going to be C and E. And then I'll say this one is B. And then over here, this is going to be point D. I'm going to put in the information I'm given. So angle BCE, this is represented by 4x plus 8. And my other angle, angle DCE, is represented by x plus 2. So drawing the diagram just helps me make sense of everything I'm given. And now I can use my angle addition postulate and the definition of supplementary angles to write and solve an equation. So our definition of supplementary says that if I add these two angles together, because I know they're supplements, I know that they have to add to 180 degrees. And then substituting in what we're given, 4x plus 8, and then our other angle is x plus 2. Altogether, this is going to be 180. So let's start by combining like terms. 4x and x is 5x. 8 and 2 is 10. And subtracting 10 from both sides, we end up with 5x is equal to 170. And then dividing by 5, looks like we end up with x is 34. And now that we know x, we can take that, do a little back substitution to find out how big these angles are. So I'm going to work with the one on the right because that looks easier to work with. So the measure of angle DCE, instead of x, I'll substitute in the 34. So we get a total of 36 degrees. And now that I know that's 36, I could substitute in 34 to find my other angle. But because we know that these are supplements to each other, I know they have to add up to 180. So instead, I'll just do 180 minus the angle we already found. And that tells me that my other angle is 144. So here's our two angles. So there's an example working with supplementary angles. Write and solve an equation, take our value for x and plug it back in. Let's do one more example where our information is given to us a little bit differently. So this one says the measure of an angle is 1.5 times the measure of its complement. Find the measure of each angle. So it looks like it's not giving us a whole lot, but it is. It's giving us everything we need to know. So right away, I do see that word complement. So I know that my two angles have to add up to 90. And that's the other piece. I know I'm working with exactly two angles. One of those angles is 1.5 times bigger than the other one. So let's start with a picture to help us make sense of this again. So if these are complements, I know they have to add to 90, which means they're going to form a right angle if they're right next to each other. And we need two angles, so I'm just going to split this. Okay, so now the way that this information is given to me, one of the angles is 1.5 times bigger than the other one. Okay, I don't know how big that other one is either, so why don't we just start with a variable? So because I don't know how big it is, let's just say it's x degrees. If that's x degrees, my other angle is 1.5 times bigger than that. So it's going to be 1.5 times x. And together, these two angles are complements, so that means they have to add to 90. So if I take x and my other angle that's 1.5 times bigger than x, together, those have to be 90 degrees. I can add these two together. This is 1x plus another 1.5. That's going to be 2.5x. Or I could write this as 2.5x. And then dividing by 2.5, this is going to tell me how big my first angle is. So I end up with x is equal to 36. So that means that this first angle, this angle is 36 degrees. And if I want to find out how big my other angle is, I can take 36 and I'll multiply this by 1.5. So 1.5 times 36, that is 54. So my other angle, 1.5 times bigger than 36, this is 54 degrees. And that does check out. 36 and 54, together that gives me 90.